All right, guys, we are ready for lesson 5, talking about solving multi-step equations. We're taking it a step further. We have talked about solving two-step equations, solving equations with variables on both sides. Well, now we're doing multi-step equations, which means there could be two, there could be more than two, but we know that we're going to have to do several things to an equation in order to get the correct answer. Okay? This is lesson 5. This is the last lesson in chapter 2. So be ready to do a test over this chapter within the next couple of days. Okay? Also, don't forget that you should be doing your vocabulary for chapter 2 to get ready, because you will have vocabulary on the chapter 2 test. So our vocabulary for this particular unit is null set and identity. Okay. So let's start talking about this. The first thing that we're going to talk about is right here. We are talking about a lacrosse team. And if you don't know what lacrosse is, just some background knowledge, it's where they throw a ball and they catch them in these baskets. It's a lot like soccer, only instead of using your feet, you're going to use this basket. So you can try to score goals. So we are talking about a coach who wants to get new lacrosse uniforms. And if we look at this, well, the first thing after you read this, the first problem, or the first question, says circle the variables above and underline what they represent. So we're looking for letters by themselves. Well, if I look through this, the first letter that I come to is P. So I'm going to circle that variable. And then what does it mean? Well, I have to look around that variable to see what it means. Does it mean, let's see, P on her women's lacrosse team? No. For all the players, P. So it would make sense if P, sorry about that, let me get that off of here. It would make sense if P stood for players. So in this case, our P is going to stand for players, the players on the lacrosse team. And if I keep reading, each shirt costs $20. There's an additional cost, D, so there's another variable, for a player to put her name on the shirt. Well, D represents a cost. That was what D stands for. Now, why they didn't use C, I don't know. I would have used C, but in this case, the authors of this book use D to stand for additional cost if they want the name on the back of their shirt. So use the steps below to write an equation for the total cost. Well, this is why they didn't use C, because now they are using C, and C is the total cost. So it's going to be the cost of the shirt. If they want to put their name on the back, they add that to that, and when they add them together, that gives you the total cost of the shirt. So we've done step 1. Step 2 says write an expression that represents the cost of one shirt with a player's name on it. Well, if we go back and read it, it says that every shirt costs $20. So this information we already know. It's $20 no matter if they get their name on it or not. If they get their name on it, there's an additional cost, and they represented that by D. So this is the cost of the shirt, which is $20, the cost of the name that we don't know, which is D. Then it says use the expression to write an equation that can be used to find the total cost if every player on the team ordered a shirt with their name on it. So every player on the team ordered this. Okay? So we know that every player on the team is going to order the shirt. Every player on the team is going to get their name on it. And now we have to figure out how many players are on the team. Well, if I look at this, Coach Everly wants to order uniform shirts for all the players, P, on her women's lacrosse team. So we don't know how many players there are, but we know that it's P. So it's going to be however many players there are times the cost of the shirt plus their name on it. Okay? So suppose the total cost for 15 players. So now we know P. It says that P, the number of players, is 15. And they bought the shirt plus their name on it, and the total cost, it says the total cost for 15 players to buy the shirt is $420. So this becomes $420. Okay? We still don't know how much it costs to put their name on the shirt. So this part is still an unknown. We don't know what the cost to put their name on the shirt is. But we know now that we have 15 players doing that, and that when we add those together, we get $420. So in order to write that equation, it would be 15 times 20 plus D equals 420. Okay? Hopefully it asks us to solve that later on, but that's all we need to do for that. We just need to write the equation. It doesn't say anything about solving it, it just says write the equation. Let's look at the next section. Well, now we're actually going to solve it. In order to solve that, this is the same equation from problem 1, we have to do the distributive property, which means we have to take 15 times 20, and we have to take 15 times d. That's how you distribute. You take the outside number times everything inside the parentheses. 15 times 20 is our 300. 15 times d is 15d. Now we solve this like every other equation we've solved. We draw the line down, subtract 300 from both sides, and then divide by 15. So the answer is it's $8 to put the name on the back of the shirt. So let's look at example A. I'm going to write example A on a separate sheet of paper just so I have enough room to do all of the work. So I have a -3 times 9 plus x equals 33. Now remember, you have to do the distributive property first. So I'm going to take a -3 times 9, which gives me a -27, and a -3 times x, which gives me a -3x. So if I got rid of those parentheses, I would have a -27 minus 3x equals 33. That's all I've done is get rid of the parentheses. And hopefully you remember in the order of operations that the P stands for parentheses, so I have to get rid of those first. So now I draw my line down. I'm going to focus on my variable side, and I want to move everything not connected to the variable, which is a -27. So I'm going to add 27 to both sides. Then my 27s are then gone. Bring down your 3x, your -3x. Don't lose that negative. It's super, super important. My -3x and a 33 plus 27. 7 plus 3 is 10. 3 plus 2 is 5, plus 1 more is 6. Okay? Now I want to get this variable by itself. And as it stands right now, I'm taking a -3 times x. So I'm going to divide both sides by a -3. So I have an x left over. 60 divided by a -3 is a -20. Okay? If you have questions about that, make sure you come in and ask us. Let's go on to the next example. We're going to kind of fly through these because we should be getting better at this. Here's the next example. Again, the distributive property, only this time I have to do the distributive property on both sides because I have 2 sets of parentheses, and then you follow the steps. So let's do an example with that. Let's look at C. Again, I'm going to write it over here so that I have plenty of room to show my work. You guys really hate the showing my work part, but believe me, it helps you in the end. I know you don't see it right now, but it is so easy to get confused on these problems, and it's so easy to miss a step. So if you write down your work, not only will you keep yourself in check for understanding the steps that you've done, but if you get it wrong, we can always go back and look at your work to help you find your error. Showing your work is super important, whether we're talking about math or whether we're talking about taking an order at a restaurant, or whether we're talking about taking a phone call and a message from mom and dad. You have to write down everything that's important. And in math, showing your work is the important part because it helps us identify your mistakes. So let's look at this problem. Well, first I have to get rid of the parentheses here. So I have a 3 times 6 and a 3 times a -4x. 3 times 6 is 18. 3 times a -4 is a -12x. So to get rid of the parentheses in this first part, I end up with an 18 minus 12x. I also have to get rid of the parentheses on this side of the equal sign, so I have a -2 times 6x, which a -2 times 6 is a -12x. And I have a 2 times a -9. 2 times a -9, or 2 times 9 is a -18. So here's all my stuff without the parentheses. So now I just have to rewrite it. Well, I have an 18 minus 12x on this side equals a -12x minus 18 on this side. Well, holy cow. If I look at that, my 12x's are both negative, And I have one positive 18 and I have one negative 18. Okay, let's look at that again. If I look back up here at my work, which is why it's important to show your steps, you have a negative 12x and a negative 12x. So those are identical. 18 is my answer to the first one. Negative 18 is my answer to my second one. And I believe I am doing that wrong. I did tell you that wrong. Holy cow, I forgot this negative on this too. Guys, do you see why it's so important to show your work? I made a mistake. And I would have never known that if I wouldn't have shown my work. I would have just said, oh, well, I don't know the answer. I can't get it. So I'm going to let Mrs. Neely or Mr. Neugebauer tell me tomorrow. But because I showed my work, I now know my own mistake. I forgot that negative on that too. So now I have a negative 2 times a negative 9, which gives me a positive 18. Wow, that changes the whole thing. So now I have a positive 18 and a positive 18. So if I look at that, all of my numbers are the same on both sides of the equal sign. If all of the numbers are identical, so this side equals this side perfectly, then my answer is infinity, or all real numbers. Any number will work in there because this side equals this side. So let's say I put a number 4 in there. Well, last I knew, 4 still equals 4. So if I put a 4 on this side and I put a 4 on this side, they're still going to equal each other. If I put a 25 in on this side, I have to put a 25 in on this side. Last I knew, 25 equals 25, so 25 would work. If I put a negative 5,275 on this side and a negative 5,275 on this side, well, they equal each other, so that would work. So the answer to this one is called infinity. What your book calls it is the identity of all real numbers. Mr. Neugebauer and I are perfectly okay, though, if you just put the infinity sign, because essentially it means all numbers, no matter what, positive or negative, fractions, decimals, however you write them, any number will fit into that problem. So that the answer to C is infinity, or the identity of all real numbers. Now let's look at number D, or letter D. Again, I'm going to write this down so that I have plenty of room to do it. D says I take 2 times 3x plus 5 equals 5 times 2x minus 4 minus 4x. Whew, I about ran out of room. I almost didn't give myself enough room. Same thing, I'm going to multiply to get rid of parentheses, so I have a 2 times 3x, which gives me a 6x. I have a 2 times 5, which gives me 10. So that side of my equal side is done. This is where my equal sign is. Now I'm going to take this 5 times everything inside of there. So I have a 5 times 2x, which is a 10x, and a 5 times 4, a 5 times a negative 4, which gives me a negative 20. So now let's look at this. This 4x, don't forget to put that back in it whenever you rewrite your problem. So on this side of the equal sign, this part right here, I have 6x plus 10 equals, on this side I have 10x minus 20. Don't forget your negative 4x that I did nothing with so far. Now if I continue combining like terms, well, I have a 10x over here and I have a negative 4x over here. So I can combine those. 10 minus 4 is 6. So I have a 6x plus 10 on this side. On this side, 10 minus 4 is a 6x on this side minus 20. Now, if I go back and I look at my problem, my 6x's are identical. Well, right away you should be thinking this is going to be what I had over here. It's going to be infinity. But if I look at the rest of the numbers, a 10 and a negative 20 are not the same. If they are not identical, then my answer is going to be no solution. I can't solve that. Because if I put a 1 in here, I still have to add 10 to it. So 1 plus 10 is an 11. If I put a 1 in here, I have to subtract 20. 1 minus 20 is a negative 19. They are never going to equal each other. No matter what number I put in there, there is no way that this problem where I add 10 and subtract 20 is ever going to be the same. So my answer is no solution. In your book, this is called the null set. Null means not solvable. So this is the null set. I cannot solve that. At no time will they ever be the same. Because on one I'm adding 10 and on one I'm subtracting 20. They cannot be identical. Okay? We're going to go ahead and stop the video there because that's the basics of it. As far as writing an equation, you should be able to write an equation from words. We have worked extensively on that in this chapter. Okay? So I'm going to stop the video right there. Write down your questions, bring those into us, show your work. And we look forward to seeing you tomorrow. Have a great night.